All right. You guys have a test Wednesday, and that test will cover all of Chapter 5. But you've already done the study guide for some of Chapter 5, so I'm going to give you some problems aside from the study guide, and they're going to be off of that test that you took previously. We worked every single one of these problems in class, so you should have them corrected on your test. If not, you need to get with somebody in class and get them corrected. So on test 5, you can go ahead and get that out or write these numbers down. You need to be able to do 3, 4, 5, 6, 7, 9, 11, 14, 15, 17, 18, 19, 20, 22, and 23. So those are the ones off of test 5 that you need to be able to do. Again, we worked every one of those in class, so if you do not have those, you need to either get with me after class or you need to get with somebody in class and get those problems. Do I need to call out the list again, or do you have them? Does anybody need the list again?
Yeah, I can go over the list again.
Okay. From test number 5, you need 3 through 7, 9, 11, 14, 15, 17 through 20, 22, and 23. You're welcome. All right, so that's the problems off test 5. And again, we worked every one of those problems in class the other day. So again, you should have them corrected. If not, like I said, you can see somebody in class to get them, or you can see me after class, and I'll be more than happy to work them for you or give you the correct answers. Now, as far as your study guide is concerned, here, we've already done some of these problems, so I'm not going to give you credit again for doing those. But these will be the problems for your test number 6. So on page 269, you'll need to do numbers 2. And then on page 271, okay. So again, you'll need to do the problems that I called out from test number 5, and you'll need to do these problems. These problems are the ones that I want you to turn in for bonus points. If you want to rework the problems from test number 5 and attach it to those, I'll give you points for that as well. It'll be the same 10 points. So any questions about study guide, what you need to study for your test on Wednesday? Any questions at all? Okay. So let's go back. We've only got a few more things to talk about in Chapter 5. So we've been talking about roots and radicals, talking about square roots and cube roots and so on and so forth. Well, now what we're going to do is we're going to talk about merging exponents. Look at definition 5.7. If you have a power that is raised to a fractional exponent, if you have a base that's raised to a fractional exponent, what you're looking at is you're looking at a radical. Okay? So when you write these, it's always your base is going to be your radicand. That's what's going to go underneath. Your top number is going to be your power. and your bottom number is going to be your index. So it's always going to be power over index. Power over index. So watch this. If I have 25 to the 3/2 power, okay? 25 to the 3/2 power. 25 is going to go underneath the radical symbol. My index is 2, so we're taking the square root of 25. And then we're going to turn around and we're going to cube that answer. So you know that the square root of 25 is going to be 5, and 5 cubed is 125. Okay? So just always tell yourself power over index. Power over index, because that's how it goes. Anytime you have a base raised to a fractional exponent, it's going to be power over index. So let's watch this one more time. Notice here we have a negative exponent. Can't deal with negative exponents, so what we're going to do is we're going to do 1 over 32 to the positive 2/5. 1 over 32 to the positive 2/5. So we're going to have 1 over 32 is your radicand. That's what goes under your radical symbol. Your index this time is 5, and your power is 2. So can you imagine what the 5th root of 32 is? It's something times itself 5 times. That number grows really, really fast if you think about it. So it has to be a small number. It would have to be 2. So you're going to have 1 over, the 5th root of 32 is 2, and then 2 squared, so you get 1/4. So be careful with your negative exponents. See if you can do negative 64 to the 2/3 power. You should have negative 64 underneath your radical symbol. Did everybody get that far? Okay. What's your index? What root are we taking? We're taking the cube root, the 3rd root, and then our power is going to be to the 2nd power. So the cube root of negative 64, what do you think? Cube root of negative 64 is going to be negative 4, and negative 4 squared is going to be 16. Good job. Very good. Okay. This one, notice there's no parentheses here. So the negative has to go outside. Your 8 is going to go under. Okay. That negative sign is not attached to that 8. What root are we taking? Cube root, so the root of 3. And then it's raised to what power? The 1st power. So the negative sign tags along. Cube root of 8 is going to be what? 2, and 2 to the 1st power is itself. So your answer is just negative 2. Are we good? Power over index. That's what you got to tell yourself. Power over index. Okay, so why do we need to be able to do that? Well, watch this. To write a radical expression using positive rational exponents, and this is important, positive, we don't need anything negative. Rational exponents just means a fraction as your exponent. That's all that means. Rational exponents just means your fraction, you have a fraction as an exponent. Okay, so again, you know that your index is your denominator, your exponent is the numerator, and the radicand is your whole number base. Okay, so we're going the other way. We started with it looking like this. Now we're going to end with it looking like this. All right, so watch this. Your index here is 2. The very first one. Your index is 2. How do I know it's 2? It's an understood 2. There's not a number written there, so it's understood to be 2. So your index is 2. What is your power? 1. You don't see any powers, so it's understood to be 1. What is your base? Anything underneath the radical symbol is your base. And we're going to put that in parentheses because it is a product. So you have x, y, and then for your exponent, it's power over index. What did we say the power was? What did we say the power was? 1. What did we say the index was? Power over index. Power over index. Now, this answer is perfectly fine for me, but if you do this problem on your study guide and you look in the back of the book, the answer is going to be written like this. You remember your product to a power rule? Remember if we have something like, well, I'll just do this. If we have something like x, y to the third power, each factor gets that 3. So you get x to the third, y to the third. Do you remember that? Okay, that's what's going on there. All right, let's try this one again. If you have the fourth root of a cubed b, watch this, watch this. What is going to be your base? A cubed b. That's going to be your base. Because look, if we had a power, it'd be written like this right here. Okay? So, our base is going to be a cubed b. And what is our fractional exponent going to be? Power over index. What's the power understood to be here? 1 over what? 4. And then what we're going to do is we're going to multiply. Power to a power, you multiply. A to the third to the 1/4 power is going to be a to the 3/4. B to the first to the 1/4 power is going to be b to the 1/4. Again, it's that same rule that we've been dealing with since the beginning. Okay? A power, a product to a power, each factor gets multiplied by that exponent. So you get x to the third, raised to the third is going to be x to the 9th. Y to the first, raised to the third is going to be y to the third. So you're multiplying those exponents. So 3 times 1/4, you can put that in your calculator. 3 times 1/4 is 3/4. And then there's understood 1 here. So 1 times 1/4 is 1/4. All right, let's go one more time. Look at this pesky little 4. Where does it need to go? Is it included in our radical? No, so it needs to go on the outside. What's our base going to be? Raised to the what power? 1/3. Power over index. It's 1/3 power. 1/3 power. Again, if you're looking at roots, you're looking at a fractional exponent. Okay? If you're looking at a root, you're looking at a fractional exponent. So it's the 1/3 power. So let's finish this up. We're going to have 4 times x squared to the 1/3 is what? X to the 2/3. And however you want to write that's fine. Okay. Can you tell me the difference between this radicand and this radicand, aside from the variables, of course? What mathematical operation do we have here? What do we have here? So my question to you is this. If I have something like x plus y raised to the 4th power, is this what you're going to get? No. Do not do that. You cannot distribute a power across addition sign. So we're not going to be able to do this rule that we learned here because of addition. You cannot do that. All right. So our base is going to be x plus y. And again, what's our exponent going to be? Power over index. 4/5 power. Good job. Okay? And don't distribute that. That's not going to be x to the 4/5 plus y to the 4/5. Why it is that we have to know how to go from a fractional exponent to a radical and from a radical to a fractional exponent. There is a reason why we have to do this. When you multiply powers, what do you do with the exponents? You add them. When you multiply powers with like bases, and you know this, x to the second times x to the third is going to be what? X to the fifth. When you multiply powers with like bases, you add those exponents. This is not to be confused with a power to a power, which is when you multiply. Okay, don't confuse these two. When you multiply powers with like bases, you add those exponents. So, look, for the one on the left, right here, we are multiplying a monomial times a monomial. We did this early in chapter 3 actually. Early in chapter 3. You're going to multiply your coefficients. So 3 times 4 is going to give us 12. And then you're going to multiply your x's by adding the exponents. So watch this. You're going to have x to the 1/2 plus 2/3. Put that in your calculator. Put 1/2 plus 2/3 in your calculator and tell me what you're going to get. Okay? In your calculator, 1/2 plus 2/3. So you're going to get 12x to the 7/6. When you multiply powers, you add those exponents. That's a rule that you've known for a while now. You're just dealing with fractions. Okay, let's look at this. Power, or product actually, to a power. You know this rule. Product to a power. Everything gets squared. So we have 5 squared. We have a to the 1/3 squared. And we also have b to the 1/2 squared. Well, 5 squared you know is 25. A to the 1/3 squared. Power to a power, what are you going to do? Multiply. So you're going to get a to the 2/3. 1/3 times 2. Put it in your calculator. 1/3 times 2. It's going to be 2/3. B to the 1/2 times 2 is going to be what? B to the first. And you don't have to write the 1. And again, in your calculator, half of 1, or half of 2. Half of 2 is going to be 1. So again, these are rules that we've dealt with this semester. A lot. Just now we're dealing with fractions. So look at the one on the the third one, I guess. When you're dividing powers, what do you do with those exponents? You're going to subtract. So, watch this. Let's do our coefficients. 12 divided by 6, what are you going to get? 2. 12 divided by 6 is going to be 2. Now, y to the 1/3 divided by y to the 1/2. Watch this. Y to the 1/3 minus 1/2. So in your calculator, do 1/3 minus 1/2 and tell me what you get. Is that good? So what are we going to do? Because remember, the 2 has its own exponent. The 2 has its own exponent, so it needs to stay where it is. The only thing that you're going to flip is the thing that has the negative exponent, which is going to be the y. Okay? So you're going to have 2 over y to the 1/6. All right. Let's look at, let's move this out of the way. Let's look at this one. So now what we have is we have a lot of things raised to the 4th power. Everything inside those parentheses gets raised to that 4th power. Everything. How many things are in here? 4. There's a 3, an x, a 2, and a y. All 4 of those get raised to the 4th power. All 4 of those. So watch this. We're going to have 3 to the 4th. We're going to have x to the 2/5 to the 4th. We're going to have 2 to the 4th. And we're going to have y to the 2/3 to the 4th. Everything is that 4th power. Everything. So in your calculator, 3 to the 4th power is going to be what?
81.
And then x to the 2/5 raised to the 4th. What are you going to get? X to the 8/5. Again, if you need to, put it in your calculator. 2/5 times 4. 2/5 times 4. So on bottom, 2 to the 4th is going to be y to the 8/3. 2/3 times 4. Again, put it in your calculator. So question. Can I reduce 81 over 16? The best thing to do is put it in your calculator. 81 fraction bar 16. 81 fraction 16. Now what's going to happen is it's going to give it to you as a mixed number. You know how to change a mixed number to an improper fraction. And it'll tell you straight up, no, it will not reduce. So 81 over 16 won't reduce. Can I reduce the x and the y? In other words, can I combine, can I divide powers with unlike bases? No. You have never heard me say that. You can't do anything with powers with unlike bases. It's only powers with like bases. So that's your answer. You can't do anything with that. So again, all 4 of these problems are rules that we've dealt with before. It's just now we have fractional exponents. Okay, but the rules are the same. Are we good? Do we need to practice this, or are you okay with this? It's calculator work, basically. If you don't know how to add the fractions, subtract the fractions, and multiply them, use your calculator. Okay? Now, look at this. We're going to put it all together. We're going to put it all together. All 3 of those slides that we just went through, we're going to put it all together right here. Watch this. You need to put a big old star on this slide. A big, huge star. Because this is something that you're going to have to study, practice, 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 and study some more. Okay? Watch this. To multiply or divide radicals with different indices. We haven't done this yet. Everything that we've done are like or have the same indices. In other words, you know that the square root of 2 times the square root of 3 is the square root of 6. But look at your indices. They're both 2. Indices is just plural for index, okay? Your indices are both 2. So we can do that. As long as your indices are the same, we can do the math with them. But look here. What is my index for this one? 2. What is my index for this one? You cannot do this. You cannot do this straight up. You just heard me make the statement, you cannot multiply radicals with unlike indices. So put that in your brain. Because on the test, half of you are going to try to do it. And you can't do it. So what are you going to do? Watch this. Step number 1. Change from radical form to exponential form. What is the square root of 2 written as a power? 2 to the what power? Thank you. Power over index. When you see a radical, you're looking at a fractional exponent. It's 2 to the 1/2 power. Times the cube root of 2. What's that going to be as a power? 2 to the 1/3 power. Now look. We're multiplying powers with like bases. You're multiplying powers with like bases. What do you do with the exponent? You add them. Your base, is that going to go to 4 or is it going to stay as 2? Stays as 2. Leave it alone. What's 1/2 plus 1/3? Okay, so one more time, watch. Step number 1, change from radical form to exponential form. From here to here, from radical to exponential. Step number 2, apply the rules of exponents. Those are the ones that we learned in chapter 3. Step number 3, make sure you change it back to radical form. What is 2 to the 5/6 written in radical form? What's your radicand? 2. What's your index? What's your power? Okay? So you got to remember those 3 steps. If you're multiplying, now look, on the exact same test, and I don't want you to get this confused, okay? On the exact same test, I will ask you in one problem, in one problem I will ask you to multiply the square root of 2 times the square root of 3. And you're going to tell me it's what? And then right around, maybe even the next problem, I'll ask you to do this. Please, I am begging you, do not tell me that this is some root of 2. You can't do it. Here your indices are the same. Here your indices are not. If your indices are not the same, you have to go through those 4 steps. If your indices are the same, it's just as simple as multiplying. Okay? So be careful of that. Don't get these 2 confused. All right, let's look at this one. You tell me, what do you want to do first? I don't care. Some people will see it and some people won't. Reduce. Good. Square root of 4 is what? 2. And the reason why I would like for you to do that first is because it's going to make your basis be the same. It's going to give you the same base. Okay? The square root of 4 is going to be 2, and then the cube root of 2 you can't do anything with. From here, you're going to want to multiply, and I don't know why, but you're going to want to multiply the top and the bottom by the cube root of 4, which is fine because you learned how to do that previously. But watch this. This is going to be 2 to the first power over 2 to the 1/3 power, which is going to be 2 to the 1 minus 1/3, which is going to be what? In radical form is going to be the cube root of 2 squared. Or the cube root of 4. Either way. Now, if you had have gone the way that I showed you a long time ago to get rid of the cube to get rid of the radical on the bottom, you multiply the top and the bottom by a cube root. That'll give you 8, because that gets you on your perfect cube list. You're going to be testing on all this. So you multiply the top and the bottom by the cube root of 4. That's going to give you the cube root of 8 here. That's going to give you 2 cube roots of 4 here. Well, when you go down, you're going to be able to reduce the 2 and the 2, and it's going to leave you with the cube root of 4 anyway. Watch this. Last week, we're not dealing with different indices anymore, right? So this problem is solved. Since you're not dealing with different indices anymore, I can do this like we were doing last week. So we'll multiply the top and the bottom by the cube root of 4. Why the cube root of 4? Nobody knows? Because it's going to give me the cube root of 8. What's the cube root of 8? That's why. So 2 times the cube root of 4 is what? Two times the cube root of 4, what is it? No, sir. No, sir. You cannot combine a whole number with a radical. Cannot combine a whole number with a radical. So it's just 2 times the cube root of 4. Watch this. Cube root of 8 is 2. So, once once you rectify this problem, I don't care which way you go, but you've got to clear up the problem that we have at different indices. You got to clear that problem up first. Once you clear that problem up, you can go this way, which is what we did here, or you can go this way, which is what we did last week. That's completely and totally your choice.